Good. So today it's going to be more focused on slope, and our slope is often called a rate of change. Okay. So we're graphing real-world situational problems like science-type graphs. We're looking at a rate of change, and you got to focus on your units. What's the units for the top of the slope, and what's the units for the bottom of the slope, because those help us describe what's happening. They give us information, which is why your teacher always says, label your graph. The other focus will be on your axes intercepts. Okay, and those help give us meaning. Usually it's kind of like a start and a finish for the graph, okay? And gives us meaning to what happened as well as the title. Right, Chase? Yes, it does. So, looking right here, we have a hot air balloon, has an altitude of 1236. Then it begins to descend. What does descend mean? Means decrease. So that's the word we use a lot. You need to know that vocabulary. What's the opposite of descend? Ascend. Okay, and what does ascend mean? Ascend means increase. Okay, so descend is decrease, ascend is increase. We use those words a lot. It descends at a rate of 10 meters per minute. Now that's the rate of change. It's 10 meters per minute. But how can we represent the number and the word descend? What kind of number would represent the word descend? Negative. Okay, so our rate of change actually equals negative 10 meters per minute. So what that means is we are starting up here at 1236 and we are going down, and what's probably going to happen at altitude 0? What is that? What's happened there? On the graph, we're at 0 in the hot air balloon. What does that mean? Yeah, we're on the ground. We landed. Okay? So you got to use your knowledge to interpret it with the picture of the graph. So let's start this. Without graphing, what are the intercepts and what do each represent? Okay? So real quickly, here's 1236. And then we're going down. Okay? So here's your y-intercept. What does your y-intercept represent? When? So the altitude or height, depends on how you want to phrase it. But when? What? At the start of the descent, right? The altitude at the start of the descent, or the start of him decreasing his height, or at the beginning. Okay? So what does our x-intercept represent? Well, our x-intercept, that's going to be 1236. Oops, 1236 meters. And we can do what with that? Okay. 1236 meters divided by 10 meters per minute. And that's going to equal 123.6 minutes. So that's going to be the what? It's going to be the time of the descent. All right, so it's going to take the time to land. Okay, what is our rate of change? We've already talked about that. It's negative 10 meters per minute. Okay. And why do we have to have the negative sign for the rate of change, but I didn't use it when I did my division? Yeah, the negative sign is just to indicate you're decreasing your altitude, that you're going down. So what would be your independent variable? Would it be altitude or time? Does altitude depend on time, or does time depend on altitude? Well, the altitude depends on time. So our independent, let's write this down, altitude, altitude depends on time. So what we're doing is a depends on sentence, okay? Altitude depends on time. So our dependent variable would be altitude, and our independent would be time. Okay. So graph the balloon's progress from the moment it ascends until it reaches the ground. So this is an important part. We have 1236 meters. How many squares do we have? 1, 2, 3, 4, 7, 8, 9. So we have 9 squares. So we're quickly going to go 1236 divided by 9 to see what value each square should represent. So you take your maximum number divided by 9, and we get 137.3. That means we can't have anything less than that. We should always be looking to round up. What would be a nice number to graph then? 140 gets a little weird though, because then you're going 140, 280, so on and so forth. What would be an easier number than 140? 150, right? So let's go round up. So let's say each square represents 150. So this is a height of 0, height of 150, 300. See where I'm going with this? 450, a little bit easier to count. Although 140 wouldn't have been bad though, right? It wouldn't have been horrible. Where are we? 600? 750, 900, 1050, 1200, and then 1350. Okay. So we're at 1236, so we're a little bit above 1200. So we could put a dot right here. That's going to be one of our intercepts, approximately there. And that's why we found the intercept, is because sometimes it makes it very, very easy to graph. Okay. Now our time was 123.6 minutes. And if we count our squares, 1, 2, 3, 4, 5, 6, 7, 8, there's 9 squares as well. So what can we go up by then? So it'll be 123.6 divided by 9. We can go up by 13.7. So that's kind of a weird number. Again, round up. What do you think? Yeah, 15's easy to count by. So let's go up by 15's for time. Okay. So we go 0 minutes, and then we go 15, 30, 45, well, that's easy. 60 minutes, so that'd be 1 hour. Then 75, 90, hour and a half, 105, 120, and 135. So this will be time. And the units are minutes. We should always label and put our units in brackets because that helps us with our slope. It tells us stuff, okay? And again, it is down below here and it is up here with the H. But let's just go ahead and label it height and be in meters, okay? So we have to now plot our x-intercept. And that's at 123.6. So that's going to be just a little bit more than 120. And then what do you think we're going to do? Connect them. Okay. So using a ruler, whoa, that's a little thick. Why is that so thick? Let's try there. There we go. And that's the line representing the balloon, okay? A nice steady rate, which is kind of what you want when you're in a balloon is descending. You don't want to have to instantaneously decrease your height. That would be really rough ride, okay? So what about the domain and range? So your domain, that's going to be time. So you start at 0, okay? And so we can say t or x, whatever you want it to be. And it is continuous. So t is greater than or equal to 0, and 123.6 is our maximum. Okay? Remember, it is continuous. That is why we are going to be using US. That's why we do the inequality. Whereas our range, that is the height, our maximum is 101,236. What's the minimum for the height? German, what do you think? Was it on your phone? The minimum for the height would be 0. Doesn't make sense to go below 0 because that would be really hard to do, okay? And so that could be our y values, and we would have equal to signs there as well, okay? Now, in function notation, you guys remember how to do that? It's been a while since we did that. We take our equation, okay? And so we're going to say the height, let's go y equals mx plus b. And so y equals negative 10. X plus 1, 2, 3, 6. So that's our y-intercept and our rate of change or slope. So instead of y, we're going to write the letter h or altitude, whatever you'd like to use, of x equals, and it's not x we're using, we're going to use t. So negative 10 t plus 1, 2, 3, 6. Now you can see here they use the letter A, so you could also say capital A at t equals negative 10 t plus 1, 2, 3, 6. Okay? So to find here, what would you do? You'd substitute in. So now you go A at 45 equals negative 10 at 45 plus 1, 2, 3, 6, negative 450 plus 1, 2, 3, 6, and so you get 786. .786 meters. Okay. Any questions? So really what we're doing is formalizing, just really making it formal, what you've done before, have always done with graphing and reading them. But we're going to say, okay, what's the beginning value, what's the end value, what's our intercepts, what's our slope, looking at our rate of change, etc., etc. So throwing a lot of vocabulary in there, okay? Next one here at the cell phone plan. So looking at the words, we're going to make up our equation, okay? So this is a little dated, okay? So we're not paying for text messages anymore. You pay more for data. But in the old days, they were going to float the idea that it'd be 15 cents for each text message. That would cost you a lot of money now, wouldn't it? So monthly fee is $20, 15 cents for each text message. Usually the word each or per or 4, those are all words to indicate your rate of change. Now, I know last year you didn't do a lot of word problems. And this year for systems, we're not going to get to a lot of word problems either, okay? But usually those words indicate rate of change. So write an equation and function notation to model this situation. This monthly fee, this would be your constant. Every month you got to pay the same value, and your constant is always your y-intercept. So we can take the 15 cents and go right into an equation. The cost for a phone depends on the number of texts. So I'm going to use the letter T in my function notation. So my rate of change is 15 cents per text, so it's 15 cents times T, plus my monthly fee, which does not change. Okay. So 0.15 is your rate of change, and your monthly fee is 20. Those are the two parts you got to find. Okay. So, cell phone bill is $22.25. How many texts did he make? So that becomes your cost. So you substitute that in, and now you work backwards to find the number of text messages. Okay. So bring 20 to the other side and subtract. And then you get 2.25 equals 0.15 times T. And then you divide. So 2.25 divided by 15 cents means you sent 15 text messages. Okay. Is this data discrete or continuous? How would you indicate that on a graph? What do you think? Yes?
I think it's discrete.
Why?
I think you can't attach the points because...
So if it was discrete, yeah, you wouldn't attach them.
No,
You wouldn't connect them.
No, you can attach them.
You can.
Like decimals, because they're easily in between.
Interesting. So you're thinking, looking at the decimals, and I did talk about that, right? If there's decimals, right, the costs, you can break that dollars down to smaller units. But what are you graphing though? You're graphing cost, but what's the other variable? What are you graphing? The text. What about texts? Yeah, texts are whole numbers. You only send a whole text. You might screw up and put only a couple words or letters in there, but the whole thing gets sent. Imagine you're looking at your phone and you only got half a message, and the other half went into, I don't know where. You would be pretty choked, wouldn't you? You wouldn't be able to read and make sense of anything. We always receive a whole text message. It might be a crappy message, and we may not want to read it, but it's always the entire message that was sent we get. So, is this discrete data or continuous? It is discrete. And that's because texts are whole numbers. So what would you do then? Would you connect the points or not connect the points? You would not connect the points. Unless what? Unless very large numbers. Right? So for example, if you're if you had 0, 100, 200, 300, you would probably just have point values. But even if you had maybe like 0, 1,000, 2,000, 3,000, you might still just have point values. because the numbers aren't that big. But what if you had this? 0, 10,000, 20,000, 30,000. Well, you know what? Those numbers are so large. Now you might actually connect the points, because there's a lot of numbers between 10,000 and 20,000, aren't there? So to show that, you would probably draw your lines, okay? But if there are smaller numbers, you probably wouldn't draw your lines. But guess what? Even when I draw my lines, what kind of data do I have? I still have discrete data. It's just that the numbers are so large, it makes more sense to draw them then. Okay? Which is why, with all this COVID stats, they're drawing lines. They're not making dots. Why? Because the numbers are so large. People are a whole number, okay? But the numbers are so large, and number two, they're actually a lot of times using percents. So you'll see the word per capita, which means per person, and you also see the other thing you're going to see is the percentages, like percent positive rates and stuff. So they're not actually graphing a person, but they're graphing rates, which you connect the data to because it's more continuous. Okay? So just want to know if you're watching the news. That's why. What would be the best way to express the domain in this relationship? So looking here for costs, I would probably have a minimum. So I'd probably have a 20. And then I'd probably go, each text is 15 cents. So 20.15, 20.30, and then I would go ... and then I'd do my maximum value. Okay? Or you go ... to show the pattern. Okay? So this is kind of showing that it continues forever in that pattern. This one would be a weird one for domain and range. Okay, so this cost would be your range. Then for your domain, what would be the smallest number for your domain? 0. It'd be weird, but if you send 0 text, that would be your domain. And then a 1, then 2, and then ... to show the patterns. Here, you might even want to say something like whole numbers. Okay. I wouldn't even bother going down that road. I think that would be fine for domain and range. Okay. Any questions? We're not going to do the next two because they're a little bit weird. And this is more than what we want to do for what we want to do. Let me have a look at your